Presentation, I will explain how to perform analysis of covariance known as ANCOVA in SPSS. When doing analysis of covariance, there are a number of assumptions that need to be satisfied, and in particular we'll concentrate on assumption number 6 and assumption number 7. So the assumption number 6 states that covariate should be linearly related to the dependent variable at each level of the factor, and there should be homogeneity of the regression slopes, which means that there is no interaction between covariate and independent variable or factor. So let's have a look at the data sample. So we have a set of participants, so in total we have 45 participants, and in this particular study we looked at how participants identify with the brand. So we have our initial identification with the brand, and the lower score presents the higher identification. So basically we ask participants question, how representative this brand of you and how well you identify with the brand. And then we give people some time to explore the brand, browse through their website, and then we ask them for their second identification with the brand, and again lower scores represent higher identification. And there were 3 groups of participants. So the participants who just looked at the usual brand were used control, white or white model dominated brand of one body type. Then we had the second type of the website where people engaged with the website and they had models of different body types. And the third website, people were viewing it, and the models on the website were of diverse body types and also diverse ethnicities. So basically the idea is, do people identify with the brands better the more characteristics are representative of that individual? So the data set looks like this. So the pre is the initial and the post is the second time identification. So to perform the analysis of covariance, you'll go to Analyze, General Linear Model, and in this case it's univariate because we'll use as the first identification as the base score. So we equate people on their base score, and we're only interested in how the kind of use of diversity of models helps with the identification of the brand after people had a chance to interact with it. So we'll go to the first thing. We'll need to, however, test the assumptions of linearity, and that needs to be covariate related with the dependent variable at each level of the factor. So the easiest one is to split the group. So we'll go to data and ask to split the file, and we want to compare the groups for different groups. So we press OK, and then we basically just build the graph, the scatter plot, to look if the relationship between the DV and the covariate is linear. So we go to Graphs, Chart Builder, and we choose scatter dot. So the first one will drop there. And initial identification is our covariate, and second time identification is our dependent variable. And we press OK. Okay, so now we have our 3 plots. So this one at the first level of covariate shows linear relationship. The second level of covariate shows linear relationship, and first level of factor, second level of factor, and third level of factor. They all show linear relationship. So assumption of linearity is satisfied. The next assumptions we've got to test is homogeneity of regression slopes. So if we'll go to analyze a general linear model univariate, and now we assign our variables, how we want to assign them. So the factor will go to the fixed factor. Initial identification is our covariate, so it goes to covariate box. And second time identification is the dependent variable, so it goes to the dependent variable box. Now we need to specify the model because we need to look at the interaction between our factor and the covariate. So when you click on model, by default you have a full factorial model chosen, but we want to build the interaction slope. So we would want to have a main effect of group, a main effect of our covariate, and then an interaction term between the group and covariate, between factor and covariate. We press continue and we press OK. So the one table we're interested in this, oh, sorry, I forgot to unsplit the file. Okay, splitting file, analyzable cases. I was thinking why the output looks so weird. So press OK and just repeat the steps. Whatever you pre-selected, SPSS saves it, so we can see that the model we specified is still in there. So press OK. Okay, so here we have 15 people in each group, and one thing we're interested in this row, group times pre, so factor times covariate. And this interaction basically tests if the regression slopes are different. And if the result is not significant, that means that there is homogeneity of regression slopes. For a matter of fact, it's not very usual to find the significant result, but it's very important to check that this assumption is satisfied. So now that we have two main assumptions checked, we can perform analysis of covariance. So you go to Analyze General Linear Model Univariate. We already assigned all our variables where they need to be. Now we just need to change the model to full factorial. We press continue. Then you may want to select some other options, but a good idea is to, in the options, select descriptive statistics and homogeneity tests. We press continue and we press OK. Okay, so this is the main output for the analysis of covariance. So the Levine's test that tests the homogeneity of variances across group is not significant, so that assumption is also satisfied. And the main output that we're interested in is this test of between subjects effects. So what we can see is our covariate and our grouping variable, kind of which brand people interacted with or viewed and how they reported the identification. So the way you interpret the results of the covariance is that having diversity within the brand, so each level of diversity, are significant. So the effect of diversity is significant, and that is controlling for the initial reaction of participants to the brand. So what we can see from descriptive statistics is that highest identification was where brands were diversifying in body types and ethnicities when presenting their garments on models, slightly less when it's just with the body type, and the identification was very low, um, because the high score represents lower identification in the control setting with the standard one. So the ANCOVA showed that there is overall difference between the three presented options, and further analysis needs to be done to look at pairwise comparisons to find out where the difference actually lies. But in its principle, this is the how you perform analysis of covariance.